Hi, welcome to this new video. In today's video, I'm going to be showing you how to build the REST API using Spring Boot. Also, we're not just going to be implementing a REST API using Spring Boot, but also we're going to be implementing a cache system. This cache system will consist in integrating that cache system that is already built into the Spring Framework module. Whenever we are building a Spring Boot project, it is already integrated into our Spring Boot project because Spring Framework is the big umbrella and Spring Boot is just one module to optimize and automate the process of building REST APIs like we are going to do in this video. Also, for you to see in a nutshell how Spring Boot optimizes and automates the process of building REST APIs, I am going to be only building one table into the database that we are going to be building with MySQL so that you can see what we can do with Spring Boot and the simple configurations that we can do and be able to, with the minimal configurations, do much better. So if you would like to see how I build the REST API using Spring Boot and also integrating a cache system for optimizing queries for the database, stay in this video. Also, before passing to this tutorial, I just want to make sure that you subscribe to this channel. It doesn't cost at all. Just hit that like button and subscribe to this channel. So, having all that said, I want to thank you, and without any further ado, let's get started with this tutorial. So, before passing to make the REST API, we have to also always initialize the Spring Boot project with the Spring Initializer. So in this page, we are here into start.spring.io and we can here initialize our Spring Boot project. Now look, we can make our custom configuration here, but in this video, we are going to be leaving it as default, as presented right here, because we are not going to be needing more customization, because that's the only thing that we are going to be using in this video. So like the language is for Java, the project we're going to be for the building packages, we're going to be using Maven, and with regards of the Spring Boot version, we are going to be using the latest version at the recording of this video. The date of this video is the 3.4.5, so we're going to be leaving it as right there. Also, what we're going to be selecting is the group name that we're going to be giving is the name that we're going to be giving to the main package. In this case, I'm going to be putting com.therealcodeshow, and the name of the artifact we're going to be giving the name of REST API. So you can see here that it write itself automatically by the project's name. The main package are going to be having into our project, and the description we're going to be leaving as right there. The packaging and the Java version we're going to be leaving as default. So now with the dependencies part, that's the main part and the most important one, because that's the place, here's the place where we can choose and select what dependencies we are going to be using alongside the project and the pieces that are the fundamental parts for our Spring Boot project. Now, the main one to make the Spring Boot a REST API is the Spring Web module. And you can see here that when I write here web, you can see here that there are a lot of modules like Spring Web, Spring Reactive Web, Timelive, and other related modules that are related when we write the web word. Now, when building RESTful APIs, like you can see here for Spring Boot web module, this is capable of doing build web, including RESTful applications using Spring MVC. It uses Apache Tomcat as the default embedded container. So this is what our Spring Boot project are going to be executing, because it automatically embeds and an Apache Tomcat. So we are going to be selecting first the Spring Web. This is the most important module. Take note of this. Now, what we are going to be using regards of the database, we're going to be using JPA because it will automate and optimize a lot when consulting and querying data to the database. Also, what we are going to be needing is the Lombok library because it optimizes a lot and deletes a lot of cumbersome code when coming to the topic of making getters and setters or even constructors. You are going to be seeing that we are not going to be making the dependency injection via the fields side because that's not the focus that we want to take, because this is not the most recommended approach, but the constructor approach. And you will be seeing that Lombok library takes importance in here. Also, what we are going to be integrating is the dev tools, because this is the module that whenever we are ready with the changes in our IDE with the project and we change to another window, the project will automatically execute without requiring to us manually clicking the play button to execute. So you can see here that this is a lot of automated work right here. And also what we are going to be needing is the MySQL driver, because without the driver we wouldn't be able to connect to any relational database, in this case the MySQL database, like we are going to be using it. If it's Postgres, then you will be needing the Postgres driver. If you are working with a non-relational database like MongoDB, then you will be needing some configuration part based on that database, non-relational database. And so this is all of the setup that we are going to be using. If there's more that we want to integrate, and I may have missed it in this configuration, then I just can go right here and type start.spring.io and integrate the another dependency that I want to integrate later when we are writing code. And this is a day-to-day operation, because we are not always set up when building a Spring Boot REST API, but we in the road are going to be implementing more dependencies. So that's the daily process that every Java developer or Spring Boot developer faces when building REST APIs, consulting this page every time. So if you are comfortable with all of the dependencies that we are integrated here, like you can see, I have hit into the Explorer part here, and you can see that I can see here the dependencies that I'm going to be integrating automatically into my project once I download it. You can see here that it is written already into a pom.xml file. And if you are good with this, you are ready to go to download it and start open it from your IDE. You can see that I am going to hit here download, and I am going to be in this case saving it into the desktop folder, because for more fitable operations here. And you can see here that it's a basic process here of just downloading and saving as a zip file, and then you just decompress it and you open it from the IDE. So I am going to hit here save into the desktop file that I have right now, and the next step that we are going to be doing is open the project from our favorite IDE. In my case, I am going to be using IntelliJ IDEA Ultimate version. So let's pass to the next section. So as the next step that we have to do when we are building an API is to create the database. So as I said at the beginning of the video, I was about to be creating only one table into the database, and the database will consist on only stored products. And now the products table will have only the name, the description, and the price. That's not more than just that logic. And the next step that we have to do is to execute this SQL that I have already prepared. You can copy it and execute it in your client of your relational database. In my case, I am using MySQL Workbench. So you can see here that I have already created this database and the table as well. So now we are going to pass to the code and let's see how to connect with the database. So as the next step is to open our project that we just downloaded from the starter of Spring. As you can saw that I downloaded it to my desktop folder, and you can see here right now that I am going to be searching it to the desktop folder, and you can see here right now that I have already decompressed it and saved it into the same folder of desktop. And now I'm just going to be clicking it, and I'm going to be clicking on Trust Project. So now you can see here that it's already loading. And let's wait to get it all completed. Now that we have it already loaded, our project, you can see that here is created our entry point, that it is annotated with the Spring Boot application annotation. So this is meaning that this will be our entry point. Now, the first step to think when building a REST API is how are we going to be structuring our project. In this case, in this video, I'm going to be structuring it by 4 main packages: the controllers, the models, the repositories, and the service layer. Each one of them are going to be having separated by its responsibilities. For the service, will be consulting the repository layer and then offering the data to the controller, and so on. So you will be seeing there the execution and the logic between them. So the first step, we are going to be creating the packages. As I have already mentioned it you, I am going to be creating the controllers package. Also, I am going to be creating the repositories package. Also, I'm going to be creating the models and the service package, services. Also, as a recommendation, always put your package's name as plurals. So this means that we'll be holding more than one class of each layer. So now, given that you have already created your packages, you can the first step that we can take here is to connect to the database that we have already created. So how do we do that? So as a first step, we can do the connection by just heading to the application.properties here. You can see that I have entered to the resources package, and then I click the application.properties file you can see here. And then the only thing that it appears to be showed here is just the application name that is named REST API. But as I told you that with the Spring Boot, we can optimize a lot by just requiring minimal configurations to do a lot with just the minimal effort. So this is done by the helping of the Spring Boot module and with collaboration of the Spring Data JPA. So what are we going to do to connect to our connect to our database? So in this case, I am going to be typing this property here. You can see that I am going to put Spring Data Source URL. So this is going to be meaning that we are going to put here the URL and specifying the port that will be hosted our database on. So in my case, will be hosted in 3306. So this is like a general pattern for all of the machines, that all the databases are only are always be hosted on this port. So we are going to be typing MySQL /3306/ and we're going to put the name of the database that we have created. In my case, I have created REST API. Then we are going to be putting the data source, and we're going to put Spring Data Source and then the username. we are going to be specifying the username here, and in my case it's root. And then you are going to be putting your password, so that you are going to be putting your real password. In this case, the AI will suggest me a general password, but you are going to be putting your real one. In this case, you can see here that here the AI puts me this value, but this is not the actual password of my MySQL client. But you can see here that the property here is spring.dataSource.password equals to my new pass. In this case, is the password that the AI thinks that I'm going to be using. But you, instead of this, you are going to be putting either your username and also you are going to be putting your real password. Now, given that these three properties that is going to be given to the Spring Data JPA get to know all the credentials that are going to be used to connect to your client of MySQL, you got to get it to know a little more of detail. For example, you can, in this case, I am used to integrate this another property that I can use for whatever SQL statement generated by the JPA. I can see it in an SQL format in the console, so I can make sure what Spring Data JPA is making behind the scenes, and I can also monitor it. Also, another thing that I am always used to put is to put the properties here, hibernate.format SQL, so I can see in a formatted SQL. Here I see in the console, and then I see it here in an SQL format. And you can optionally you can put the port that your application will be hosted on. In this case, you can put 8080 or 8081. The thing here is that you make sure that that the port that you are going to be placing here, make sure that it is available for the web application hosting here. So it's more recommendable not to touch this. In my case, I am not going to touch this. I am going to delete this property. So automatically it will be executing on port 8080. Now, as the next step, given that we are here just by doing this, we are connecting to the database already. And that's incredible because we are not doing a class dedicated for just creating the connection, and then we put the connection and then the statements, and then we create a pool of connections, and then we close the connection manually. So all of that cumbersome process is now deleted, and Spring Boot is making our lives easier by just requiring us the minimal effort of just configuring by the application properties or any other file that of configuration that you may have into your Spring project. So now this is all for the application properties. Now, if you want to visualize your database into your IDE, this is an extra point here. You can go down here to MySQL, and you can choose this selection here. It will then appear this window, and you can put here your host, the port of that the database is actually running on, and then the method of authentication. You are going to be using either username and password authentication or no authentication, whatever your method of authentication you are using based on your client of your database engine. In this case, if you are using username and password method of authentication to log into your database, then you are going to be using here the username and password like we have done into the configuration files, because it will be requiring your root username and also your password. And if you want to connect it, you are going to be putting here the username. In my case, it will be displayed as root, and then I am going to be putting here my uh, my actual password here. You can see here that I can put the database here. You are going to be putting your database name. In this case is named REST API. You can see here that I am going to be clicking on test connection, and we have just to wait. And you can see here that it is succeeded because my connection hasn't failed at all. And therefore my IDE is now communicating with my real database. And you can see here that it's on my right side a panel that will be displayed my database with its table contained. And for more control, this is like an extra tip for you to take into account if you don't want to be consulting each time to your client. In my case, if I'm using my SQL workbench, not to be consulting in every time because I can do it here from the IDE. Now, given all of this, we can just freely go to code in each of the packages we have created. Now, the most important thing to note here is that we have a table that is named products. Spring Data JPA needs to map it because Hibernate it's a mapper. It's a technology that maps and needs entities to be created to map the table that is located in the database. So in this case, it's an ORM, object relational mapping. It has I have forgotten the word. Now, the first step that we gotta take is to create the models. Now, the models will be representing the entity of the database. In the entity will be representing the table that is contained. In this case, I am going to be naming it the products entity. So in this product entity, the first thing we're going to be doing is just to annotate it with the entity annotation, and also I am going to be annotating with the table annotation because I want to give it a name that is to be specific, because there might be some redundancies in the long term. So it's more recommendable to put the table annotation always when we are creating a model. Now, as we have the ID representing each record in the database, we are going to put these annotations. You can see here that the first annotation I'm putting is the ID and also the generated value. Now, the strategy of the generated value, because my ID is auto incrementable, I have to tell to Spring Data JPA that it has to be creating whenever I save a new record. Spring Data JPA has to prepare a new key so that the strategy has to be of auto generation type, and then Spring Data JPA will take charge of saving the new record into the database. So you have to put these statements here to tell Spring Data JPA that you are going to be using your ID as an incrementable type. Now, the AI is suggesting me here that I can use generic generator, so it's recommendable for you to put here. And then by just doing this, I'm going to import here, given that I see that is giving me an error, but there's no problem. Now, below this, you are going to be putting your ID field. In my case, because it's a type of integer, and you can see here that it's a big int translated to a Java code, it could be integer type. So there's no problem here. Now, we are going to be creating each field to Spring Data JPA to map all of my model, and for him to have the relation to my table set into my database. Now, I am going to put here the private string name because it's the name of the product. Also, I'm going to be putting the description and the price. Now, you can see here that this is a typical class of a Java class, right? But to convert it to a POJO, because it's the plain old Java object, but this has to be mapped by Spring Data JPA. And for it to be mapped and accessible to Spring Data JPA, we have to put the setters and getters. And that's why Lombok library takes relevance here, because we are not just going to be creating the getters and setters in a cumbersome way where we generate it and there's a lot of code generated like a big block down below onto the class. We're not just going to do that. We are just going to be annotating at the top of the class with getter. Here you can see that there's an annotation from Lombok that is named getter. So this annotation will be telling to the Lombok library to incorporate all of the getters that it will be injecting into runtime to this class. So we are able to have getters able to be implemented into this class. And also as the AI, you can see here that the AI is suggesting me the setters. And also you have to put the setters. Now the setter is also from Lombok. You can see here that I am importing it from Lombok 2. And also another thing that is important is to create the constructors. You know that in Java, every class has to have their own constructor. And in this case, Lombok as well do that job. You can see that I am going to put all args constructor, meaning that I will be creating a constructor with all of the args. So this was required. You can put also the all args constructor for every case. And you can also put the no args constructor, but you can't put only the all args constructor because Spring Data JPA will throw you an error. So it's mandatory for you to put, if you want to put personalized constructors here with Lombok, you have to put no args constructor. But this is optional because Spring Data JPA will handle all of this for you. But for recommendation, I will just leave it like as it is right there. So having all of this completed, we have already completed the models layer. Now, the next step that we gotta take is to create the repository layer. And we are going to be creating here, the thing that we are going to be creating here is an interface. This interface will take the responsibility to communicate with the database, and given that we are going to be implementing a JPA repository interface, it will have all the accessibility to functions predefined for us to just implement it into our code whenever we want it, just to call the repositories and then access into the methods predefined by Spring Data JPA. So this is the magic of Spring Data JPA with conjunction with Spring Boot. Now, the interface that we're going to be creating, we'll be naming it as product repository. And here you can see that it's a simple interface, but the special thing that will convert this normal class as a bean, because we have to convert it as a bean because we are here into Spring framework. We have to convert it into a repository. So this is an annotation, the repository annotation that is going to be identifying this class as a bean, as a repository type. Now, the next important thing is that the thing that I was telling you that we are going to be extending the class that is consisting of JPA repository. You can obvious all of the things that the AI is suggesting me there. Just focus on that. I am going to be putting here the JPA repository because I am going to be extending here, and it suggests me two parameters. The first parameter it will be suggesting me is the name of the class of the model that we have created in order for Spring Data JPA to get to know which class it is going to be mapping and getting related with the tables into the database. So in this case, if I want to map the products table of my database, I have to tell to Spring Data JPA which class it corresponds to in order to be mapping that table from my Spring code. In this case, the class that corresponds to the products table in my database is the products entity. That it's the class we have just created now. Now, the name of the class was products entity, right? So you have to just put here products entity, and the second parameter that is that is required is the type of the ID that we have just placed. In this case, you have to put the integer because we have created our ID field as a big int into the database, right? But into the class of our Java class, we have just created as integer, and you can see here that is a type of integer here. And so therefore we have to just put here the integer class. You are not just going to put int as the primitive type. No, you are going to put the name class of the type we have just put. And now that's all. We have already available here all of the methods like save, read, save by ID, and all of that methods that JPA repository provides to us. And you will see that into the service layer. And that's the thing that we are going to be creating, right? That's the thing. So we are going to be heading out to services. We don't have to wait for more. We can just create it now. Now, the product, the class name that we are going to be creating will be product service. There's no more science there. Now, here's is the thing, and the more where the more content will be placed. Now, why am I telling you this? Because here in this layer is the place where all of the cache system will be residing, because we can't be just putting into the controller layer, because the controller layer is just only meant to be dispatching, requesting and response and offering the data to the user, right? And if we put all of the responsibility of caching the system there, we are going to be mixing all of the responsibilities, and that's not a good practice. And we can't put as well into the repository layer, because we are going to be mixing as well all of the responsibilities that doesn't correspond at all to that layer, because repository, we know that it communicates to the database only for communication to the database and querying and modeling. It's not viable. Now, the main thing and the only alternative is to put it into the service layer, and that's why we are going. That's what we are going to be doing. Now, to identify this class as a service component, we have to annotate it here simply by just putting @service. No more. Now, in this case, to enable the cache system, because we want to have it all set up in order just to implement it into the service layer, there's a prior step that is required before implementing the cache system itself into the service layer. Now, there's only one annotation ahead, right? And as you can see here, the AI has already spoiled you, and we are going to put here enable caching, right? That's the annotation that the AI has suggested, and it was right? This was the only enough annotation for us to enable the cache system. So this is all, and we are freely just to use the cache system into our service layer. Now we are going to be seeing how to implement this cache system into the service layer. You are going to be heading now to the product service again, and take a look at this. We are going to declare as a final property the product repository field, right? So we are going to put here product repository, because we are going to be creating a type of the product repository, an object. So this is going to be giving me an error because this is declared as a final. But here is the thing. We can auto-wire because we intend here to make a dependency injection, because that's what the capabilities of Spring Boot offers to us. Instead of creating product repository equals to new, you can see here that this is the traditional approach, and then you make a lot of cumbersome code there. I'm going to stop this because I don't want to opt for this way. And you can see here that this is the traditional way, but as you can see, there's a lot of ways. Well, there are 3 ways to auto-wire, make dependency injection through the field way, through a setter method, or through a constructor. Now, I can do here through a field method to just put auto-wire here, but this won't be viable because this is a bad practice. And for another videos, I am going to be explaining why this is a bad practice. And what we can do for now is that I want you to understand that the approachable way and the recommendable way is to inject it through a constructor. Now, here's the thing that I mentioned you that was important to integrate Lombok library into our project, because we are not going to be creating the constructor manually. And as you saw before, when I was creating the model, I wasn't creating the constructor manually, so I just integrated 2 annotations, and you can see there that the 2 corresponding annotations that I am telling you is all args constructor and no args constructor. And so for making the dependency injection here, I will be requiring one of them to inject the dependencies. And the annotation that I am talking about is to use all args constructor. And you can see there that the error has gone, because when we declare as final, we are telling to Spring Boot and in Java, to Java in general, because this is a Java principle, that if you declare a property as final, it won't be replaceable in the future when executing in runtime, because it will be unique. And this is a good practice when we are building REST APIs. Now, we have to go to the grain, right? We want to save a product, and there won't be a cumbersome code here because the process is very simple. You can see here. Take a look at this. Product entity. We are going to be creating the function to save the product. We're going to be returning a type of product, and the AI has already spoiled you again. Now we are going to be naming this function as save product, and we are going to be admitting a parameter of type products entity because we are going to be receiving it from the controller. Now the product here, and the thing that we are going to be using is to return. And now here takes the responsibility our repository layer, because we are going to be using the methods predefined that I have mentioned at you, that by extending here this class, it brings me a predefined methods such as save. You can see here that there has flush, save and flush, delete in batch, get one, get by ID, find all. There are a lot of methods, right? And one of those methods we are going to be using to save the product. Now we are going to be returning, because we are going to be returning a products entity type, and we are going to be calling the product repository, and we're going to be telling to save the product that we just passed as a parameter. Now, you want to see how to implement cache in this whole thing, right? And we can start by here. When we save a product, we can also cache it and save it into random memory, so that when we request again the same data, we are not going to be requesting that same data to the database, but we are going to be requesting it to the cache. Sorry. So when we save a product, what we need to do is, given that we are going to be having a place where we are going to be having all the data cached, and that names will be all products. You can see here that I am going to be annotating here as cache evict, and evict, this will be evicting all of the list contained with all of the data that are going to be placed into the cache. And this suggests two parameters. The first is the name of the cache that my list of products will be hosted on, and if all of the entries will be affected, meaning that if I have 50 rows, then the 50 rows will be affected, will be evicted. Now, if I tell it as all entries equals true, then obviously all the entries will be affected. Now, I can already save a product here, but obviously I have to call this method from the controller, and that's the only thing that it's just left. Now I want to raise myself here in just creating the other methods. You can see here that I am going to be creating another method, and in this case I am going to be creating let me see, I have a misspelling here. I am going to be getting all of the products because we are just returning a list here. You can see here that I have to import it from the Java util, and then I want to return from the repository, product repository, and we just have to call the method of find all, because find all is meaning and telling to Spring Data JPA to catch all of the records from the table, and then it will be returning it as a list of products entity. There's no more science there. I will write down all of the methods, and then I will be getting into the cache system. So after writing get all of the products, I am going to be writing the method of delete the product, and in this case I'm going to be putting the delete product by ID. I pass as a parameter the ID, and you can see here that the AI is suggesting me here that I can just call by the repository the delete by ID method that is already predefined by the JPA repository, and I just passed here the parameter of the a parameter of integer type, and just passing it as a parameter to the delete by ID method. Now, after this, I can write down the another method in behalf of the updation of the products. Now I am going to be writing it products. I am going to be returning a type of products entity, and I will naming this method as update product by ID, and I will pass two parameters. The first is the integer that to identify the product that I'm going to be updating, and also the products entity object to catch the new data that has been sent from the HTTP client and therefore catched by the controller. And you can see here that the AI was suggesting me here a lot of code, and I am going to be pressing tab because it's all correct, and I'm going to be explaining you. So here the first thing we do is to save into an object here the searching of finding by ID any product that is identifiable with the ID passed as a parameter, and if anyone matches with the value that has been passed as a corresponding to the first parameter, then it will be catched and saved into this variable or this object. And otherwise, we are going to be throwing a null value. And depending on the value that has been saved into this object, we are going to be evaluating here by just writing this logic. And you can see here that we have I have just put the if statement, and if the existing product is different from null, meaning that if the repository, in this case JPA repository, has found any object or any record identified by its ID that I have passed as of the first parameter, then that means that there's a product existing, right? And so the only thing that I will be doing is to get this existing product and set the name and set the new name that has been sent by the second parameter that is of type products entity. And in this case, I am going to be getting the new name and setting into the old one that is existing product, right? Because that's the object that we want to update. And we do the same for the following methods here. And by the end of this operation, we can just return, because we have just placed here into the method to return a type of products entity to denote to the user that the object was successfully updated. And in this case, if the updation is successful, we are just going to be returning the method. Now, to return here, we are calling the save method too. And why is this occurring again? Because save, I have already used it in the first method to save a new record. But take a look at this. Spring Data JPA understands and it's smart enough to identify if a record is used to be updated or if it's used to be saved as a new record. So in this case, the save method will be used in the context of updating a new record, because the Spring Data JPA has already took a look if the record has already into an existence into the table. So if there's into an existence there, that means that the product into existence will be updated and not just saved as a new record because it has already an existence, right? And what we are going to be saving is the whole object of the product that we're going to be passing. In this case, we're going to be passing before known as the old one, but now is the updated one. And that's why we are going to be passing the whole object here. And otherwise, we are going to be returning null. There's no more science here. So to end this part off, I just want to terminate this with the cache system. Now, to integrate the cache system here, you can see that I have already used one annotation on behalf of the cache system, but there's not all, because this is only evicting whenever I save a product to update or to delete all of the records that the cache system had already. But those records, whenever I save a new record, will become the old one because they won't be updated and won't be in matching corresponding to the records that the database has and the cache has. So they won't be the same. So that's why I evict the cache whenever I save a new product. Now, when I retrieve a product, I have to catch them all into one place into the cache system. And the name that I am going to be giving to the cache system is going to be named all products. So how do we do that? With the cacheable annotation. And here, there's only one parameter that this annotation suggests to us, and it's the value. And here we put the name of the place into the cache system to store all of the lists that are going to be returned. So the plane here is like the following. We request here, we call this method, and then the method returns this list, right? Because the method is suggesting to return a list of products entity. But at the time that we retrieve and get all of that list, automatically Spring Boot will save that whole list into this place named all products into the cache system, so that later on that we request again and we call this method and we haven't saved by that time any new record, then all the list, instead of being retrieved from the database directly, Spring Boot will throw the same list, but now thrown from the cache system. And this is all covered from get all products. Now, when we delete a product, we want to evict, because we are going to be affecting one record into the database. So if it's there an affection into the database, there has to be an affection therefore into the cache system to be matching all of the two systems. So in this case, the thing that I have to put here is also a caching, a cache evict. Again, another cache evict annotation here. And as you can see, there suggests me two parameters here to put. So I will give it a tab here. It just disappeared. Here it is going to be all products. It is going to be evicting all of the products and will be identifiable by its ID. And the only thing left to do here is that we can, whenever we update a product, I just can evict again. Whenever I update a new product, I want the cache system to update as well. So it's the same playing here. I'm going to be evicting every time I affect any record into the database. So I want to get the same data as the database has. So this is all for the service layer. So as I told you, this has the strong part. This is the strong part of the REST API, because the service layer, as you know, is like the brain of all of the, in general, of all the applications, but in REST API, it's not the exception. And the only thing left to do is to write the code of the controller. And let's take a look at the controller now. Now, in regards with the controller methods, we are going to be creating a new Java class, and we are going to be calling it as the product controller. Now, as you can see here, it's like another normal class, Java class, but the differentiation here is that we have to identify it as a bean, and we are going to be identifying it as a REST controller bean, because it is combining the notation of controller plus response body. And response body is the key differentiator here, because response body will return any metadata value, whether it could be JSON format or XML format. That's why response body comes into play here. And after annotating the class as a REST controller, we are just going to put here a request mapping to identify the controller. And in this case, I am going to be identifying this controller as /API products. And we can put another parameter just to tell to the Spring Boot that we in this controller we can produce either XML value or JSON value. And to tell that, we are just going to put here the produces parameter, and you can see here that I'm going to put media type dot application down slash JSON value and XML value. Now I have to import here the class of media type, and you can see here that it's already good. Now, having all of this set up in terms of the controller, we can go on with the content of the controller. Now, the next step that we have to do is to inject the product service class that we have just created before, that is located into the service layer, and as well in the service package. Now, the same thing is that we are going to be doing. We are going to be injecting it through a constructor parameter and declaring the object as a private final. You will see here that I'm going to be writing it as a private final, and I'm going to be placing here product service. So this is going to be throwing me an error, but no, there's no worries, because I am going to be using Lombok, and I'm putting all args constructor to make a constructor requiring all of the dependencies and fields that I have just declared at the class level, and the constructor will take that to make the dependency injection. Now, given that I have created a CRUD, I have to create all of the endpoints to consult to each of that functionalities. Now, the next step that I have to put here is to create the method that will correspond to the get all of the products endpoint. So I'm going to be using the get mapping annotation to tell to the Spring Boot that I'm going to be using through a HTTP request based on the get method that I want to retrieve all of the products, right? And to consult this method, I'm going to be putting get all. And I am going below this, I'm going to be creating the method corresponding to return all of in a form of a list of the products entity. In this case, I'm going to be telling the name of the method. I'm going to be making a returning from the product service and calling the method that I have created named get all products. You can see here that when I clicked control plus a click, it redirects me to this method, because this will be executing and therefore returning all of the products that are going to be contained into the repository that therefore is communicating also with the database. So this will be coming from the database at once, at the first glance, once, and then it will be cached, and from there to so on. If we make the same request, we are going to be getting from the cache. Now, this is all from get all. Now, if I want to get it from, well, if I want to add a new product here, I'm going to put here the other annotation that I have, in this case through a post method corresponding through the to the HTTP, and I'm going to be writing here the method corresponding to add product, and here I am going to put this annotation of request body telling to Spring Boot that I am going to be catching the product, the object of the product sent by via HTTP protocol. And then, as you can see here, the AI is suggesting me that I have then to save into this variable of type products entity the request body will be saved into this variable. And now we just have to call the product service we have just declared here and call the method of save product. And truly this is the one that we have just created here, because we pass the parameter of product and then we just call the predefined save method from the JPA interface. Now the next step we have to do is, in order to call the delete method corresponding to delete a product, we have to create here the delete endpoint. And so for this, I am going to be creating the method here. I'm going to be putting here the delete product, and I'm going to be catching the value that corresponds to the ID of the product, and I'm going to be catching it through the path variable annotation and saving it into this variable of ID of type string. And then I'm just going to be calling again the product service, and I'm going to be calling again my custom method I have made and pass through a parameter the ID, but parsed into an integer type. You can see here that that's the same method, delete product by ID, from my service layer. And the last one to put is the put mapping to update the product. And in this case, you can see here that the AI is suggesting me one thing here, but I have my own customization. I am going to be creating here a method of type string, and then I am going to be putting a type update product, the name of the product, the name of the method, and I am going to be using again the path variable to catch the ID passed as a parameter. I am going to be saving into this variable, and also, as you remember from the product service, whenever I call this method, it suggests two parameters. So two parameters has to be declared here as well. So the next one has to be catched from the body sent through the HTTP request. And in this case, I am going to be catching all of the value that has been sent through the HTTP request via the body and saving it and converting it as a product entity. And I will be naming this variable as product. Now, given that I have to call the service method corresponding to update the product, I have to declare a method here, an object here, and call the service layer, and call therefore the method of update product by ID. You can see here that I pass the same two parameters that I have requested here, and the product, meaning that this object will hold the new data to be updated over the existing one that is known as the old one. Now we can put just a simply logic here. If the product's entity is different from null, then the product is updated successfully, and otherwise, if it's equals to null, then the product hasn't been found. And this is all of the API, REST API. You can see here that is very simple to create an API with the Spring Boot, but it requires like a very deep understanding of what we are doing and see the negotiations within each part. Now, the only thing left here is to test it, and we are going to be testing it with Postman. So there's only one part left, and we are going to be seeing this right now. So let's pass to it. Now, before passing to the testing of the API with Postman, I want you to clarify something that maybe some of you might encounter when building your application and in order to test it. Let's see that in the pom.xml, you can see here that there's a tag of build, and it encompasses here plugins, and it has inside an excluding where with this build, it is telling to to the building that we are going to make a configuration, and we are here making the note that Lombok will be our annotation processor paths. But you can see here a little bit down, you can see here that this tag excludes, this obviously exclude the process annotation processor here that Lombok will be bringing us in order to make use of the annotations. But these will make us unable to use the Lombok annotations because it will be excluded at the time when building the fat jar that the Spring Boot will contain. So this will block our work entirely, and we won't be able to make the building. You can see here that I am going to run my application here and make the build, and you can see that I am not going to be able to do so because of this statement and this configuration that in the pom.xml resides. And you can see here that there's already here an error that has been thrown. And you can see here that the variable product service not initialized in the default is constructor. But you can see here that this is just a simple dependency injection that I am doing here by just using the all args constructor that is the Lombok's annotation. But here's all of the thing. I am just doing a simple dependency injection. But this I am not able because due to this configuration that I have into my pom.xml. So at the time that if I erase this at all, you can see here that I am going to be free to execute my project and to do a build. So now I am going to rebuild again the pom.xml. Also, the next step you have to do is to erase or delete this the target folder. You can see here in the project structure, you're going to be hitting delete in order to pump the project, the build project, to generate a new target folder so that it contains the most updated configuration of the project. You can see here that with the new configuration and with the deletion of that unnecessary excluding of our annotation processor, you can see here that our application goes normal. So with this, we are all set up to test our API with Postman. Now, here when we are in Postman, we can now consult and make requests to the controller of our API. So what we are going to be doing is first to add a product. So how are we going to be able to do so? We're going to be selecting post, and because our application is running on port 8080, we are going to be declaring localhost ;, 8080 API, and we are going to be telling API / products. Here we can put products, and then because we want to save a new product, we're going to be putting /add. So we're going to be putting /add here, and then to add a new product, we're going to be heading to the body section. We're going to press row and then select the JSON option. Now, because of the fields that we have to based on the fields names to put the values. So as you remember, we put into the model the same names that constitute the same names in the table. So in the table are mapped as name, description, and price. So these same names fields we have to put in order to send the values from this client. So for Postman, in order to send the values, we have to put the same properties names. In this case, if we want to put the name of the product, we have to adapt this following structure that I am doing here. We're going to be enclosing within the double quotes the property and double colon equals to the name that we want to do. So in this case, if I want to add, for example, if I want to add a soap, the description of the product, we're going to be saying a body's product for human utilities, and the price, because we have declared into the database the price will be a type of decimal. So here we are not going to be enclosing the value as in double quoted symbol, because this is not anymore a string. So in this case, what I have to put is the price here as just decimal numbers. In this case, let's say that it costs $2, and we're going to be hitting here send, and you can see here that the product was added successfully. Now, with the cache system, here is automatically evicting, but given that I have I haven't requested still the get all, because the get all is which is the entry point where we are going to be getting all of the products, and therefore it will all of them will be cached. So with this request, I am not caching still, but if I create another request, in this case I am going to be leaving here as get method, HTTP method, and I will be typing the same here, localhost 8080 API products, and then get all. Here, by saying get all, I am hitting this method of the controller. So now what I'm going to be doing is sending again, and you can see here that before I have added another product for just testing purposes for recording this video. So you can see here that there are 2 products right now, and now these products are now cached, because one, as I have told you before, when you request at the first time to the database, it is requested once. But if you keep requesting the same data again, then it will be no more be requested to the database, but it will be brought back from the cache system. And you can see here that if I want to corroborate that, you can see here that if I would be doing the same query, it will be appearing here. So you can see here that if I hit get all again, here by the hibernate, you can see here that I have made as insert, a select, an insert, and a select. But after the insert, that is the last product that we inserted, that is the soap that you just saw here that I have inserted it. There is only one select query here, because as I have told you, otherwise, if the caching system wouldn't be working, there would be a lot of select queries here written in the console. So if there is no more writing of selectings here onto the console, then all of the data brought back is coming from the cache system. And you can see here that we are not letting the responsibility to the database for bringing back all of this data repetitive again and again. So now if you want to delete the product, you just have to type again localhost 8080 API products, and then you are going to be hitting the method, the respective method here, delete, and then you will pass the ID of the product that you want to delete. In this case, I want to eliminate this shampoo product that is of identifiable of the number 1 as its ID. So I am going to be passing here the number 1, and you will be seeing that the product has to be deleted successfully. So now, as the cache system is also evicted, we have to consult again to the database since the cache system has been evicted, and then the cache system has to be updated again to bring us back the updated data. You can see here that if I hit again the products get all, it will be bringing back again the same results because it hasn't evicted yet. But if I am going to here delete product by ID, you can see here that I am hitting here as a key. So now I am going to be hitting all entries because I don't need to only evict one thing, but all of the entries. So that is why it's not returning the evicted data. So with this, we are going to be waiting for the application to run again. And now you can see, since the application is already loaded completely, we are going to be requesting again to the same endpoint to get all of the products, since we have deleted the product of ID 1. You can see here that the only product shown is the product identified with the number 2. So the deletion of the product has been successfully deleted. Now with the updation, we have also to make another modification here, because since it's identified by the ID passed as a parameter here, we are not going to be evicting all of the products and or as well said, the list that we are storing here in this place of the caching system. So what we have to do also is to put again all entries equals to true to affect all of the records. So now we are going to again rerun our application. Now that we have already loaded our project, we're going to be heading out to Postman again, and we want to put with the HTTP method of put, we are going to be updating our product. So what we have to do here is to, again, write localhost API products, and then we are going to be writing the path here to identify this method. So we're going to be writing /update, and then the ID of the product that we want to update. So since I want to update the only record that I have right now stored into my table, I am going to be putting the number 2. Now, since it's requesting also a product entity based on a request body, we have to send another data, like if we would be saving again a new record, but now identifiable to updation. With this, we have to make the same process as if we would be saving a new product. We're going to be hitting again to body, then raw text, and then hitting JSON. Now we're going to be making the same data structure. We're going to be putting the name here, the description, and the price. Now, given this structure, as we want to update the product of soap, we're going to be changing only the name for you to see that the updation will be taking effect. Let's change it as shampoo. The description I am going to be putting the same about is product for human utilities. And let's see that we want to update the price too. So I am going to be elevating the price as $5. Now I'm going to be hitting send again, and you will be seeing that the product is updated as successfully. So we are going to be requesting it again. So there's no be any more shown a soap record here, but a shampoo. And you can see here that is successfully um, shown and has been successfully updated because there is no more soap value here shown, but a shampoo. And the price, as you saw here in the put, we have put $5 for this shampoo. So this is showing the same. So this is all for the caching system, and you can see here that I can keep making all of the requests, and the caching system has been taken effect because when we updated our product, it uh, therefore it has been updated all of the products with all of the entries. So it evicted it, and then by the request to get all of the products, it cached again the products coming from the database.